So in this video we're going to try and find the median and the Q1 and Q3 values for a set of numbers, right there. And we're going to use those to calculate a range, an interquartile distance, and to draw a box and whisker plot for that data. So the first thing we need to think about here is how many numbers there are up there. So I think this box has 5 columns and it has 5 rows, which leaves 25 data points. So the first thing you need to figure out is how those data points would sort themselves out if you were chopping them into quartiles. So first off, you have your median right in the center, and median I'm going to label as Q2, so it's the second quartile. And then down here you'd have the first quartile, and up here you would have the third. Now before I start thinking about what the specific values are, I need to think about how the data is going to split here. So if I were to take 25 data points and try and find the number dead center, that means there's going to be 12 on this side, 12 on that side, and 1 right in the middle. So I'm going to have a value here. There's going to be 12 data points on this side of it and 12 data points on this side. If I take those two sets of 12 data points and split them in half, then this data set is going to go 6 data points here, 6 data points here, 6 data points here, 6 data points here, for a total of 24, and 1 smack in the center, right there. So if you were to think about which data point in the sequence would fall in around this Q1 area, you're going to have to go between the 6th data point, which is in this box here, and the 7th data point, which is in this box here. So I need to find something that is between the 6th and 7th. Now this data point here, the one dead center, there'll be 6 here, then 6 here, that's 12. So the next one, which would be the one right in the center, is the 13th. And once you go from the 13th up 6 more data points, you would be between the 19th and the 20th data point. And so that would leave 20, 21, 22, 23, 24, and the 25th data point as the 6 that are up here. So if I start going through my list, I'm going to look in here and I'm going to find that my lowest value in this particular set is a 3 right there. So that's my first data point. I'm going to start scrolling across. I'm going to find all the other 3s. So that's the first one. That's the second data point. The third. The fourth. The fifth. We're all out of 3s, so we go on to 4s. The 6th. This is the 6th data point right there, a 4. The 7th data point will be the next where I come to, that's here. So the value of the 6th data point was 4. The value of the 7th data point in sequence was 4. So the value for Q1 must be 4 then. Let me jot that down up here for you. Lovely. So from here, that was the 7th data point. We need to find the 13th data point in sequence in order to find the median. So if we keep going to the next 4, that was the 7th data point, 8th data point, 9th, 10th, 11th, I'm a lot of 4s, on to 5s, 12th data point, and the 13th data point in the sequence. So the median for this particular set is going to be 5. Alright, now I'm looking for the between the 19th and 20th data point. So if this was the 13th, there's my 14th, 15th, 16th, 17th, 18th, 19th, and 20th. So my 19th and 20th data points are both 6s. So my value for Q3 is going to be 6. Okay. So in order to draw yourself a box and whisker plot, you need to identify a few things on a number line. So I'll maybe draw it right here. See if that runs into my face. Like that. On this end, I need to put my lowest value in the set. And I think the lowest value I had was a 3. So I'm going to label that. I'm going to erase this here so we can see what we're doing. Maybe with some toilet paper. So the lowest data point was a 3. The highest data point I find in the set is a 9. So the 9 goes up here. And then I have to chop this up into equally spaced bits. So 3, 6 would be there. 3, 4, 5, 6, 7, 8, 9. So I have a nice number line going from the lowest value to the highest value. I'm going to draw in the value at my Q2, that's at 5, that goes here, like this. And I'm going to draw a line at my Q1 at 4, that's here. And I'm going to draw a line at my Q3, that's here. And what I've accomplished now is the box part of the box and whisker diagram. So I could shade that in there. There's the box part. The whiskers are these pieces that extend all the way down to here, to my lowest value, and all the way up to my highest value. So you can see that there. I have a box and a pair of whiskers. So what this diagram is trying to show you is that even though the range is this wide, the bulk of the data is concentrated in this box. In fact, by the nature of quartiles, 50% of the data points have to fall between Q1 and Q3. So half of the numbers in this whole block lie in that little box. So this picture is meant to show you how things are clumped, if they are clumped, or if they are spread out nicely. Last two things you can get from this, the 3 to the 6, or sorry, 3 to the 9, the lowest to the highest, that's your range. So this has a range of 6, because it's 9 minus 3 is 6. My shoulder out of the way. The last thing you can do is your interquartile distance, which I'm not going to write out here, but I'm going to abbreviate as an I for inter, Q for quartile, D for distance. And that's measuring how far it is from Q3 to Q1. So to get from 4 to 6, you have to go up 2. So there you go. I have an interquartile distance of 2. So I'm going to use the same data set here in order to construct a 5-bin histogram. Now the idea for a histogram is that each bin collects your numbers from your data set, and then each bin is a bar in that histogram when you're done with the graph. So I'm choosing 5 bins just because I like the number, because I think it looks tidy when you make the graph with a data set this size. When you do your own data analysis, you can put as many bins as you like. But if you can imagine us trying to do 10 bins with this data set, right, for 10 bars in your histogram, most of those categories would be empty. There just aren't enough numbers to fill that many bins. So a data set this size, maybe 3 bins would be good, maybe 4, 5, 6 or 7, it's going to start to be empty. These aren't hard numbers, right? There's no reason for that other than I don't want them to be empty and I think it will look bad. So I'm going to arbitrarily choose 5 bins, and because I make the assignments, you're going to choose them too for what you hand in. So when I look at this set, the first thing I've got to ask myself is what the lowest value is. So if I scan up there, I think we said it was 3. So the minimum value is 3. The maximum value that I've got in there is 9, right up in that top left corner. So the maximum is 9, which means I have a spread of 6 through my data set. Now, in the last video, we called that the range. So I have a range of 6 on this. When I make my histogram bins, I need each bin to be exactly the same width. So I'm going to take this range and I'm going to divide it into 5 bins. And 6 divided by 5 gives you 1.2. So I'm going to start with some bins here. My first bin is going to contain everything that is bigger than 3, but less than 3 plus a jump this big. So if I go up 1.2 from 3, I get to 4.2. So I want to find all the numbers that are between here. And the way you notate that is that you say that 3 is less than or equal to x, and x is less than 4.2. So those two little alligators there are showing you that the number that goes in this bin has to be between those two values. So my next bin then, you notice that this one is not equal to, so if I had a 4.2 in this list, which I don't have a 4.2 in that list, it wouldn't go in this bin because it doesn't actually fit in an equal to. So I need to start my next bin at that place. Less than or equal to x, which is less than. So if I go up this number from here, 4.2 plus a 1.2 would be 5.4. Do it again. Would be 6.6. And then up another 1.2 would be 7.8. And 1.2 up from 7.8 would get you to 9. Now, this is the only bin, the very last one, that gets a less than or equal to sign. If I didn't put that little equals there, this 9 wouldn't fit in that bin. So I allow that just for the last set. Erase this a little bit so it's a little more clear. So I'm going to start going through my set then, and I'm going to start trying to find numbers that fit into each of these bins. So 9 goes here because it is less than or equal to 9. The 6 is in this bin because it's between these two values. 3 is in this one. 4 goes here. 6 goes here. 5 goes here. 6, 6, 4, 7, 7 is between these two. 3, 6, 7. That's 2. I can see that's 2. Hopefully you can see that's 2. 5, 4, 4, 4, 6, 3, 4, 5, 8. 8 is here. It's bigger than 7.8, but less than 9. 5, 3, 3. So I have my tally charts. I have 9 occurrences in this one, and 4 in this one, 6 in this one, 2 here, hard to tell, but that is 2, and 2 here. So if I were to make up a quick little histogram here, my first bin starts at 3, then I have 4.2, then 5.4, then 6.6, 7.8, and 9. So if I come across here then, and make each of these 3, then in my first one, so 3, 6, 9 occurrences, I have to fit 11 on here. I need a bar 11 tall, something like that, for the bin between 3 and 4.2. Color that in a bit. And then I need a bar 4 high, that's about here, for the bin between 4.2 and 5.4. Color that one in. And then I need a bar 6 high, so about like this, for the bin between 5.4 and 6.6. Color it in. And I need a bar 2 high for the last two bins. So my histogram looks something like this, and it's based on taking the full range, chopping it up into 5 parts, that was a 5 there, because it's a 5-bin histogram, and then adding that number to my minimum in order to make these categories. Run through, make a tally chart just as always, and then it'll tell you how to make your bars.